Okay, here we go. So last week we spent some time on writing what we called dissociation equations for acids, right? Because we know they dissociate down the middle, all right? We did the same thing for bases, which also dissociate down the middle. And we were practicing this for acids with more than one H plus, right? Because we know they produce hydrogen. That's what acids do. And we were doing this for bases with more than one hydroxide because they produce hydroxide, and that's what bases do. Okay. A couple of you have been asking me, Mr. O, when are we going to get to pH? Well, before we can get to pH, we need to practice one thing, okay? Here is what happens when we put acid or base into solution. The H plus affects the OH minus, and the OH minus affects H plus. Here's how this works. We're going to have a very simple equation here, all right? Now, we're missing a lot of the details, but we want to get to pH, right? So we're not worried about a lot of the crazy details that we might be if we were going to go into a lot of depth. We're not. So here is a simple equation that we're going to use, all right? As far as we are concerned, whenever we see these brackets, this means concentration. Oops. Concentration of H plus. Whenever we see brackets around OH minus, this means concentration of OH minus. And of course, this is in molarity, so this would be molar here too, okay? All right. This is what we want. For some reason, in solution, the concentration of H plus times the concentration of OH minus always equals 1 times 10 to the negative 14th. This, just to abbreviate it so we don't have to write it all the time, we're going to abbreviate KW, okay? So whenever we see KW, we know it equals 1 times 10 to the minus 14th. So keep this shorter. H plus times OH minus equals KW. This is one of those 3 variable equations that we've used many, many times before, which means we can put it into one of these triangles of, well, you guys know. So it doesn't really matter what the order is. Okay? Here's what this means. It means that if we know one of these things, OH minus or H plus, we can find the other. So if we want to find OH minus, it'll be equal to KW over H plus. If we want to find H plus, it'll be equal to KW over OH minus. And let's remember that Kw always equals 1 times 10 to the minus 14th. Okay? So how are we going to do this? What is this going to look like when we try this? Because we're going to get to pH, right? So here's how this works. Let's say that we have a solution of HCl is 0.01 molar. Now, we've done this many times before, way back in chapter 13, okay? Where we know the concentration of a ionic compound and it's going to dissociate. So here is my question. We're going to have two parts to this. What is the concentration of H+? That means what is the molarity? What is the molarity of H+, right? That's what those brackets mean. And what is the concentration of, what is the concentration of OH minus? Let's do part A first. We know HCl dissociates. It's got one H plus in the compound, so it produces one H plus in solution. Well, you already know what the concentration of HCl is, 0.01 molar. You want to get fancy and write it in scientific notation, 1 times 10 to the minus 2 molar. What's it going to do when we put it in solution? Let's keep on working on part A here. We're going to get exactly the same concentration of H plus and Cl minus because there's one of each. You want to get fancy, you can write it in scientific notation. And you're saying, Mr. L, how are you doing that? How did you get that into scientific notation? Just remember how many times we're moving the decimal place to get in front of the 1. Okay? All right, that's easy. So we know that the concentration of H plus is equal to 1 times 10 to the minus 2 molar. Let's do part B. What is the concentration of OH minus? All right. Here is where the magic happens. We know this guy right here. OH minus is going to equal Kw over H plus, and you already know Kw, 1 times 10 to the minus 14th. So OH minus is going to be equal to Kw over H plus, which you already know. So you already know both of these things. 1 times 10 to the minus 14th over 1 times 10 to the minus 2. Or if you want to keep it in regular notation, that works fine too. 0.01 molar. Okay, bust out your calculator. Bang! Okay, you all remember how this works? We're going to say 1. Hang on, I got to turn it on. Okay, we're going to say 1 times 10 to the negative 14. You all saw how I did that. We're using the second button, Shift EE. You saw me do it. It's right here. Okay, here's our second button. Here's our EE button. Okay, we're going to divide this. Now, if you want to leave it in regular notation, you can. 0.01. Enter. We get 1 times 10 to the minus 12th. Right? If you want to do it all fancy, in leaving it in scientific notation, 1 times 10 to the minus 14th divided by 1 times 10 to the minus 2, you get exactly the same answer. 1, whoops, got to make sure you hit the shift button. 1 times 10 to the negative 14 divided by 1 times 10 to the negative 12. Exactly, oops, excuse me. I plugged in the wrong answer. I plugged in the answer, not the question. Don't listen to what I just did. Let me try that again. 1 times 10 to the negative 14. I should have plugged in this times 10 to the negative 2. Sorry about that. Even the pros make mistakes. It was a long weekend. 1 divided by 1 times 10 to the negative. Oh, it clears everything. Oh, I got to use the delete button. I just downloaded this cool Texas Instruments calculator app, and I'm still getting used to it. So 1 times 10 to the negative 14th divided by 1 times 10 to the negative 2. Precisely the same answer, 1 times 10 to the negative 12. Okay? That's all you do. All right, let's take this up one notch. Let's say that we were going to say we have a concentration of barium hydroxide. Let's say this is 3 times 10 to the minus 5th molar. My question to you is, what is OH minus and what is H plus? All right. Now, we've done this a bunch. We know that barium hydroxide dissociates into barium and count them, not 1, but 2 hydroxides. So that when you put 3 times 10 to the minus 5th molar barium hydroxide in solution, you're going to get 3 times 10 to the minus 5th molar barium, right? There's no coefficient there, that's a 1. But you're going to multiply this guy by 2, because there are 2 of them. So that's going to be 3 times 10 to the negative 5th times 2 is 6 times 10 to the negative 5th molar. This is our concentration of hydroxide. What is H plus? That's this guy right here. You already know how to do this. Okay? You already know Kw. Kw is always 1 times 10 to the minus 14th. And we're going to solve for H plus. So, what is our H plus? H plus is equal to Kw over OH minus. You know Kw is 1 times 10 to the minus 14th. You just found OH minus 6 times 10 to the negative 5th. Bust out your calculator. So we're going to say 1 times 10 to the negative 14th divided by, in this case, 6 times 10 to the negative 5th. There's our answer, ladies and gentlemen. Feel free to round. 1.666666 times 10 to the minus 10th. We're going to round that to 1.7 times 10 to the minus 10th. Okay? That's all we're doing. Easy peasy. Make sure you have a calculator. If you forgot your calculator at school, let me know, and I can show you where I got this cool online one, this guy right here, but it's kind of difficult to get it to work. So hopefully you have yours, okay? See you soon.